Sometimes when you come across a problem, it feels super simple, right? But just because of the way it is written and described, it becomes super confusing. One such example is add two numbers on LeetCode. It is a quite popular problem and asked in a lot of coding interviews. And when you read it, it feels pretty straightforward. You are given two numbers and you have to add them, right? But these numbers are given in form of a linked list and they are in a reverse direction as well. So that causes a little bit of confusion. Let us see what we can do about it. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we are going to discuss some of the edge cases and then we are going to see how you can arrive at an efficient solution and what are the use cases of this problem. And as usual, we will also do a dry run of the code so that you can understand and visualize how all of this actually works in action. Without further ado, let's get started. First of all, let's make sure that we are understanding this problem statement correctly. In this problem, you are given two linked lists which are storing two numbers, right? So the linked list entire on its own is one number each, correct? And the given condition is that these numbers are stored in a reverse order, where each node of the linked list is representing each digit that is present in the number. Along with it, you have certain more conditions like both the numbers are positive and even in each node, you will find positive digits, correct? Now, given all of this, you just have to return me the sum of two numbers and this should also be represented as a list in itself, where each node of this new list will represent the number. And that too also has to be in the reverse order. So what does all of this mean? Let us look at one of our sample test cases. In our first test case, you have a list that is 2, 4, and 3, and the second list is 5, 6, and 4. Now, the confusing part about this problem is, although you are traversing the list as 2, then 4, and then 3, the actual number is in the reverse order. So this number is 342 because you have to go in the reverse direction. Similarly, the next number is 465 when you read it in the reverse direction. So now you have got both of these numbers. You just have to add them. So eventually our problem turns out to be 342 plus 465 and its sum will be 807, correct? Now you have to return this result in the same format. So this digit 7, this should be the first node. The digit 0, this will be the second node. And then the digit 8, this will be the last node. So for this particular test case, 708, this list will be your answer. You can see that when you read it in the reverse direction, 807, this is in fact your answer, right? Similarly, let us look at one more test case. And this time, there's a difference between the number of digits in both the numbers. So our first number is 99999, represented as this first list. And the second number is 999, represented by my second list. You can once again see that these numbers are represented in a reverse direction. So behind the scenes, what is actually happening is you are adding 99999 along with 999, correct? And when you add them, you will get the sum as 100,998, right? And now you have to return this answer in the exact same format. So 8 will be your first node and 1 will be your last node, correct? So for this particular test case, my answer will look something like this. You can see that I can find the number when going in the reverse direction, and that is 10099 and 8. For now, if you feel that you have understood the problem statement even better, feel free to first try it out. Otherwise, let us dive into the solution. To understand this problem even better, let us look at some of the edge cases that you may encounter. So first of all, let us say I have this sample test case in front of me and I have two numbers. So you know that these numbers are actually in the reverse order. So the first thing that you should notice is that the presence of zeros in this linked list. So for example, if I add a 0 over here, right, then this will not count towards the actual number because this number will actually become 095994, correct? And this 0 does not mean anything. Whereas if this 0 was at the beginning of the linked list, then what will happen? This 0 will eventually come over here, right? And this actually multiplies the original number by 10. So this kind of becomes the first thing that you should take care about. You have to be bothered by zeros in the beginning and not by zeros at the end. The second scenario is, I know that as soon as you see this problem, you will be tempted very much that, okay, I will just convert this list to a number and then add them mathematically. So when I convert these two lists to a number, it will look something like this, correct? you add them, and okay, you found this as your answer. Now, it is very, very tempting that, okay, you will just iterate through this entire result and create a new list, correct? And that will be your answer, right? But it will only work when you are in your integer limits, or you can go up to long limits, right? But what happens if your linked list has 100 elements or 1000 elements? That means your number is 1000 digits long. How will you store that number? In those cases, all of your test cases will fail. So certainly that is one edge case that you need to be careful about. And the third edge case you need to be careful of is that what happens if your result has more digits than the actual original input list. So right now you have 5 digits and 3 digits, right? And this in turn gives you a 5-digit answer, right? But what happens if you add numbers like 99 and 9? What happens then? In your output, you will get 3 digits, right? So you need to be careful when you're writing your code and account for the extra node that you might be adding. So now, keeping all of these things in mind, we can try to come up with a solution. So first of all, what we can do is we can have 2 pointers to start off with the first list and 1 pointer to start off with the second list, right? And now what we're gonna do is we are gonna start adding each digit one by one, because you know that when we are doing addition, you start from the last digit, correct? And this in fact is the last digit, right? So what I will do is I will keep 2 variables. One is a sum and one is the carry. Now simply start adding the digits. So first of all, you will add 4 and 1, and that will give you 5. So the sum is 5 and the carry is 0. So I start off my new list and I assign 5 over here, right? Now move both the pointers to the next position. This time you get 9 and 9, correct? So its sum will be 18. Since there are 2 digits, you will not write down 18 itself. You will write down the sum as 8 and the carry will be 1. So to process this, what I will do is I will create one more node over here and assign the value 8 in here, right? After this, we will move both our pointers to the next value. This time add 9 and 7. 9 and 7 is 16, but this time I have one more carry, right? So 9 plus 7 plus 1, that will give you 17, correct? So once again, I'm gonna write down 7 in the sum and 1 will be the carry, right? So create a new node and assign 7 to it. Move to the next pointers. I move to 5 over here and notice that I am at null now. That means I do not have any more digit in the second number. So this time what you're going to do is you will take up this 5 and you will see if you have any carry. Since I have a carry, I will add 5 plus 1. So that will give me 6 and the carry is now 0, right? Just take this 6 and assign it to a new node. We are just left with the last element and we move on to 9. So this time my sum is just 9 and the carry is once again 0. So I create one more node and write down 9 over here. So you see, we have traversed both the lists and we have arrived at our answers. The addition of these two numbers will be 96785. And in fact, this is your answer. So as a result, you will just return this head node. And this in fact is your answer. Now let us quickly do a dry run of the code and see how it works in action. On the left side of your screen, you have the actual code to implement this solution. And on the right, I have these two lists L1 and L2 and they are passed in as an input parameter to the function add2numbers. Oh, and by the way, this complete code and its test cases are also available in my GitHub profile. You can find the link in the description below. So to start off things, first of all, we create a sentinel node. This is a result node which will store our actual answer, right? And to initialize it, I just initialize it with a value 0. So I will have my node something like this, correct? And I point ptr, a new variable, to my result. Going ahead, I also initialize a carry variable that is 0 right now, correct? And moving on, I start a while loop that will keep on running until both of the lists have reached their end. That means both of the lists have reached the null position, correct? And every time, what do I have to do? I have to add the 2 digits with the carry, correct? So first of all, I initialize sum and I add the carry to it. So when you're starting off things, everything will be 0, correct? Now what do? If L1 is not equal to null, that means you're looking at the first node. So what you're gonna do is you will add the first node to your sum. So currently I just add 9 over here, right? And what I'm gonna do is I do L1 equals to L1.next. So this will move my pointer to the next node. Similarly, moving on, look at the digit from the second list. L2 is not null right now. So I take up this number 9, right? And I add it to my sum, correct? And then what I will do is I will do L2 equals to L2 dot next. So this will move my pointer L2 to the next position, right? Once you have got this sum, I got 9 and 9, and that in fact equals to 18, right? But you have to split out the sum and carry. And that is exactly what I do in my next step. If I divide by 10, then I will get the carry, and that is 1. And if I do a modulus 10, then I will get the sum, and that is 8. So what happens is, in the carry, I get 1, and in the sum, I will get a 8. Correct? So you see, I am done with my first digits now. And this means I need to create the first digit of my resultant node. So what do I do now? I create a next node and assign the sum value to it. So I will get 8 over here, and then I do ptr equals to ptr dot next. So this time my ptr will point at 8, right? This loop will go on, and this time I'm going to add 9 and 9 again. This will give me 18. I have a carry as 1, so I'm going to get 19. When you divide the sum and carry, the sum will be only 9, and I will have 1 as the carry. So I will get a 9 in here, and this ptr will move to the next position, correct? One thing to notice over here is that the result variable still points at 0, because that is where we started things, right? So this loop will go on, and ultimately you will have your entire answer over here. And once you break out of this loop, if you had a carry remaining, you just add one more node with the value 1, because that was your carry in fact, right? And once all of it is done, just return result.next, because your entire answer will be after the next variable of the beginning node. The time complexity of this solution will be order of n, where n is the length of the larger linked list, and the space complexity of this solution is also order of n, because there could be n digits in your resultant list. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, I just want to say that try to think where this problem is actually used. You don't have to actually add two numbers and create a code for it, right? But then why do you even need it? Why is this problem asked? Think about it. There are data structures where you can add huge numbers, right? The number can have hundreds and thousands of digits, and then to your data structure can add them. What happens behind the scenes? This is what happens behind the scenes. So these kind of problems give you some kind of idea how a larger program is made out of smaller tiny modules, right? So while going through this problem, did some thoughts come into your mind that, okay, this could be a use case, I can use it in this scenario? Or did you face any problems? Did you find any other problems that work on the same concept? Or any other problems where you're having a doubt somewhere around this concept itself? Tell me everything in the comment section below, and I would love to discuss all of them with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, let me know what problems do you want me to solve next. Until then, see ya.